Cette conférence va maintenant être enregistrée.
Assalamu alaikum everyone. Dear participants, thank you for joining us in the fourth and final session of the risk webinar series. इन सेशंस को अटेंड करना इन फुल जरूरी है ताकि आप सब इन पर्सन ट्रेनिंग्स के अंदर कंसिडर किए जाएं. So it's important that आप जो है वो अटेंड करें लाइव सेशंस को इन फुल. एंड लाइव सेशंस के दौरान जो इवैल्यूएशन लिंक है उसको क्लिक करके अपने पास सेव करें एंड उसको फिल करें और उसके बाद जो आपको दिए जाएंगे क्विज उनको जो है ये फिल करें. इसके अलावा ये है कि जो इवैल्यूएशन लिंक है इट विल बी शेयर्ड इन द लास्ट 5 minutes of this session and this session will also be posted on YouTube. This is the fourth session and it will be presented by Dr. Philippe Stroot. Assisting him will be Dr. Hafsa Muhammad, who is an assistant professor in Khyber Medical University. आखिर में some ground rules to keep in mind. बराए मेहरबानी अपने cameras बंद रखें and please make sure to put your mics on mute. As these sessions will be posted on YouTube, these sessions are being recorded. और अगर आपके पास कोई सवाल हैं, please post them in the chat box. Do not turn on your mics and do not turn on your cameras. Right, over to you, Philippe. Please, you may proceed.
Thank you very much, Xibios. Good evening, everybody. Assalamu alaikum. So it's already the time for our last session on the webinar on biological risk assessment. And this session will be entirely devoted to questions and answers. I will try to answer the questions you raised, you posed during the 3 first sessions. So I tried to sort topics in the questions in a few topics so that they are more or less related with each other. The first topic is really about risk assessment and risk control in general. So it's not directly related to the new WHO approach, and it's sometimes a little bit about the philosophy of risk assessment. So the first question was, if we are unaware whether risk is increasing or decreasing in any lab activity, how can we check it? Actually, I'm not too sure the exact meaning of this question, but I guess the question is about not knowing exactly, feeling that there is some risk, but not knowing exactly what it is and how should we know about that and decide about what measures. So we should realize that any lab activity involves some risk for the workers, but also possibly for the community and the environment. Of course, that risk may be totally negligible, very low, and so on, to very high. And depending on that, of course, we perceive it more or less clearly. Also, the risk can be physical, chemical, or biological, for instance. And in this webinar, we address the biological risk. Actually, with respect to risk, I will ask a question. Would you cross the street with blindfolded eyes? Most people will certainly answer no to this, okay? It's true that there are some risks that appear totally acceptable and others which do not appear acceptable. If you would cross a street in the middle of the countryside, in that case, perhaps it would be possible not to look on the sides. But if you are in a busy city, it's impossible to do it. I mean, the risk is in that case is unacceptable and you would not do it. What I want to stress there is that assessing risk is a very normal behavior in life. We do it without even thinking about it. If there are things that where we don't see the risk because it's very low. Most of the time, if we see that there is some risk, it's because the risk is not so low. Also, it's an obligation for institutions, employers, and individuals to do some risk assessments when dealing with laboratory activities. So actually, we should not be unaware of the risk in a lab. If we work in a lab, we should definitely do some risk assessment in order to define that risk and to know if we have to do something and what we have to do. Second question was, do we have to just keep risk below a threshold or keep risk as minimum as possible? As I said, by instinct, most people would try to keep risk as low as possible. If it's already very low, they will not even see the risk. But if there is some risk, people will try to stay safe. That's quite natural. But zero risk does not exist, and we are always exposed to a number of risks. Most of them appear acceptable, and sometimes we think that this is too much of a risk. I won't take it. Of course, there is a balance between the risk and the benefit we could have in doing something. So from that point of view, we could say that when there is a risk, we should try to keep it to put it as low as possible. There is also the principle of continuous improvement, and that's promoted in management systems such as the Biorisk management system, for instance. With the principle of continuous improvement, we would tend to always do as well as possible, and with respect to risk, to put the risk as low as possible. Still, we should realize that reducing the risk to a minimum could have a huge extra cost, and I will mention there the Pareto principle. What is the Pareto principle? Actually, it's a principle that it's more an observation than a real rule. But according to that principle, 80% of the consequences are due to 20% of the causes. Meaning that if we work on the 20% of the causes, we could reduce 80% of the consequences. This is something which is observed in many different areas. It's much used in management. For instance, we will do 20% of efforts to reach 80% of the possible benefits. That's something which is quite often used in business, for instance, or in management. For instance, you have a tree which is full of fruits, like cherry tree or another tree with many fruits. You could reach a number of those fruits quite easily, and perhaps 80% of them with a minimum effort. But if you want to pick each one of them, in that case, it will cost you much more energy to get them, and you will also take more risk to get them. So actually getting 100% of the possible benefits may cost a lot more efforts. That's really the message there. In safety, we also use this concept because most of the time, in controlling the main cause or factors of risk may reduce most of the risk. And when most of the risk is reduced, then there would be an extra cost in trying to reduce the risk to zero. And imagine, for instance, that you have a number of practices that are already in place in the lab. The risk is very low. If you want to reach a zero risk, you would need to put much more efforts, for instance, in practices, in PPE and so on, so that it would become much too difficult to work. So in some way, it's not needed to reach a zero level because it would cost too much, but we need to bring the risk to an acceptable level. So the purpose of risk assessment is really to define what are the risks, then whether those risks are acceptable or not, and then define what is needed to reduce the risks that are not acceptable to an acceptable level. We should not have the idea to reduce the risk to zero, but to make them acceptable. And this we need to do in taking into account the resources that are available. Of course, if you have more resources, perhaps you could reduce the risk to a lower level. The next questions deal with the new biological risk assessment approach, and so the five steps approach promoted by WHO. The first question was, as per the new WHO guidelines, do we need to assess human-associated risk or not? I define human-associated risk as the risk due to human errors or failures. The answer is clearly yes. In this new approach, all biological risks and factors should be considered. So not just the biological agent and the activities, but all the factors that could That includes the facilities and so on, but also the people working in the facilities. And so we look at their competences, are their training, are their attitude, and so on. And in addition to that, WHO insists a lot on the importance of human factors. Human factors can be a cause of incident and accidents, okay? But it's also a major way to properly control risk. If we can teach, if we can show people how to control the risk, in that case, it will be much better sometimes than putting a lot of technical means in place. That's really one of the beliefs of the WHO. And so this is done through communication, appropriate training, and also the experience of the workers. Another question was, how can we determine an acceptable and unacceptable risk in the laboratory? And who is responsible for that? Of course, this question is really essential, because finally, when we do the risk assessment, we define ourselves which is acceptable or not, and that will be the basis to the actions that we'll take after that. If it's acceptable, we might do nothing. If it's not acceptable, we'll have to put some efforts in place, so some measures in place in order to reduce the risk. So how can we determine if it's acceptable or not? Actually, there are different levels for that. The general intention, the policy should come from the top management. The best thing to have there is a kind of written policy saying what they want to reach with respect to biosafety or safety. A written policy is the best solution. Otherwise, at least some indication should be there. And then when doing the risk assessment, we should use our common sense. And also one thing that can be useful to define whether it's acceptable or not is applying the question to ourselves. So ask ourselves the question, would I accept such a risk for myself? Or would I accept such a risk for someone I love, or for my children, for instance? In that case, I think we can define whether it is acceptable or not. And then we also need to have some checking on that, some safeguards, mostly to ensure that the control of the risk assessment process itself. So who should be responsible for defining if it's acceptable or not? The policy, as I said, should be established by the top management. Then, during the risk assessment, deciding whether the risk is acceptable or not should be done by the risk assessment team. They should decide. That means a number of people with possibly different opinions about that. And so the ideal situation would be to end up with a consensus, so that everybody finally agree on whether or not it is acceptable. If there is no consensus, I think we should take the most cautious approach and say that follow those who think that it is not acceptable. And then there are the safeguards, and the safeguards should be provided by some reviewers or approvers of the risk assessment. In an institution that has an institutional biosafety committee, in that case, that's really the right place to do that. If there is no IBSC, in that case, there could be another high-level committee that could do that, like, for instance, a scientific committee, a board of directors or so. In some countries, like in our countries in Europe, the authorities also, we have to submit our risk assessment, and they approve the risk assessment and the measures we propose. But anyways, if you don't have such a regulation, the approval should be internal, and so the institutional biosafety committee would be the best option for that. Another question was also about responsibilities. Who is responsible on how to make changes to reduce the risk? And I divide the questions in two parts. About who is responsible for defining how to make changes, what changes to make, and that's clearly the risk assessment team. They get the information, they do the risk assessment, and they give a general strategy that would really indicate the direction that they should reach. And then after that, step 4, they will define a number of selected risk control measures. So that's really the work of the risk assessment team. Then who is responsible for the implementation of those risk control measures? after that the risk assessment has been approved. That's the answer there is that everyone in the organization in his normal responsibilities. That's true for the top management, but also for all the intermediate management, including lab managers and for lab workers. This is something which is very important, and it's one of the basic requirements of the biorisk management system, which is presented in ISO 3501. So really, the risk assessment team defines what needs to be done, and then the implementation, when it's ready, it's the whole organization who should work at the application of the right measures. There was then a question on the progressive loss of compliance to safe work practices, and the complete question is there. It was in a COVID context, and so the managers observed that there was a lowering of the attention and the compliance to the good practices. This is typically a human factor. And this should be taken into consideration during risk assessment. But of course, if we observe some changes in the attitude of the people afterwards, in that case, we should review the risk assessment. There might be some cultural aspect to that, and also aspects related to the perception of risk. In this case, it was to the COVID context. At first, when COVID appeared, we didn't know too much about the virus, and in some way, in labs, because we want to be on the safe side, we established a number of rules, okay? But people who work in the lab, they also live in real life outside of the lab, and they might be much exposed, for instance, when they are in town, when they do their shopping, when they go to the markets and so on. And if the rules are extremely heavy in the lab and they perceive that it's out of balance when compared to the risk they are taking when doing their shopping, in that case they might lose confidence in those rules. For instance, they might think it's too heavy. I don't say it's the situation it's the explanation in that case, but it could be that kind of explanation. But anyways, what do we do when we observe something like that? In that case, we have to review the risk assessment because there is a change of attitude related to the human factors. And so again, we should gather information and try to know why there is such change, then evaluate the risk. Perhaps that change does not have an impact on the risk. Perhaps it has an impact on the risk. And then if there is an impact and we judge that it's not acceptable, we should review the strategy and the risk control measures. And then, depending on the risk control measure, we could lower the risk control measure if they are too high. But if we think they are correct, they are justified, in that case, we should communicate and explain why we do that and what we want to have those measures in place. Then the last question of this part is, are risk assessment matrices available in any website on the internet? Actually, there are two risk assessment matrices that are provided by the WHO in the risk assessment monograph. There is a simple one, the one on the top here, and a more complex and more sensitive one, the one on the bottom. More are certainly available on the internet, and I know companies that use much more complex matrices, so also with some scoring system. But my advice there would be to start using the WHO templates and use them, really get familiar with the approach, and then possibly adapt them to your own needs. But I think it's more important to get used to this new approach because it's quite different from the usual way of doing risk assessment. First, get used to it, and then perhaps think of using a different template. So Afsa, could you please summarize this part in Urdu?
Yes, sure. Thank you, Philippe. Am I audible?
Yes, Dr. Hafsa.
Am I audible? Okay, thank you. थैंक यू फिलिप। इस वेबिनार के सिलसिले के आखिरी मरहले में सवालात के जवाब दिए जाएंगे। खतरे की तशखीस और काबू पाने के बारे में पहला सवाल है कि अगर हम ना जानते हों कि लेबॉर्ट्री के किसी खास अमल से खतरा बढ़ रहा है या कम हो रहा है, तो ये हम कैसे मालूम करेंगे? इसका जवाब फिलिप ने ये दिया कि कुछ खतरात हमेशा मौजूद रहते हैं, जो कीमियाई या हयातियाती भी हो सकते हैं, और कम और ज्यादा भी। इसकी जांच पड़ताल के बगैर हमें काम शुरू नहीं करना चाहिए, और ये हमारी इखलाकी जिम्मेदारी है कि हम अपनी और अपने प्यारों की हिफाजत को अहमियत दें। दूसरा सवाल यह है कि क्या हम सिर्फ किसी खास हद तक खतरे को कम करने की कोशिश करें या इसे कम से कम हद तक लेकर जाना चाहिए? इसका जवाब यह है कि खतरा कभी भी मुकम्मल तौर पर खत्म नहीं किया जा सकता, लेकिन इसे काबिल कबूल हद तक कम करने की और मुस्तकिल बेहतरी लाने की कोशिश की जानी चाहिए। जैसे कि पेरेटो के रहनुमा असूलों के मुताबिक तकरीबन 80% नताइज की जिम्मेदारी 20% वजूहात पर डाली जा सकती है। इन वजूहात को कम करके हम खतरात को 80% तक कम कर सकते हैं, ताकि वो काबिल कबूल हद तक आ जाएं। हयातियाती खतरात को जांचने के नए तरीके के मुतालिक सवालात। पहला सवाल यह है कि क्या WHO के नए रहनुमाई असूलों के मुताबिक हमें इंसानों से वाबस्ता खतरात की जांच करनी चाहिए? इसका फिलिप ने जवाब हाँ में दिया कि हकीकतन इंसानी अनासिर सबसे बड़ा खतरा है, जिस पर मेहनत करके आप एक पायदार हिफाजती निज़ाम कायम कर सकते हैं। अगला सवाल है कि हम लेबॉर्ट्री में काबिल कबूल और नाकाबिल कबूल खतरात का तयन कैसे कर सकते हैं और इसका जिम्मेदार कौन है? तो इसका जवाब यह है कि अमूमी हिदायत आला सतह के अफसरान की जानिब से आनी चाहिए और अपनी ज़हनी सलाहियत का इस्तेमाल करते हुए जांचना चाहिए कि कौन से खतरात मोल लेने के काबिल हैं, और इस बात को भी यकीनी बनाएं कि खतरात की तशखीस का अमल काबिल भरोसा है। इस सिलसिले में हिदायत आला हुक्काम की तरफ से आनी चाहिए और इस मकसद के लिए एक ऐसे ग्रोथ तरतीब देना चाहिए जिसमें सब अफराद मिलकर इस खतरात की जांच का अमल सर अंजाम दें। ये हर शख्स की मुश्तरका जिम्मेदारी है और उन सबको मिलकर ये काम करना चाहिए। अगला सवाल अहकामात की तकमील के फुकदान के मुतालिक है। जैसे कि कोविड के दिनों में हमने देखा कि लोग वक्त के साथ साथ अपनी जिम्मेदारियों से तंग आकर या थक कर मुख्तलिफ खतरात को मोल लेना शुरू हो गए। क्या इस सिलसिले में दोबारा से खतरात की तशखीस और जांच ज़रूरी है? तो इसका जवाब यह है कि ये एक ऐसा इंसानी रवैया है जिसको लाजमन मद्देनजर रखना चाहिए और ज़रूरत के मुताबिक खतरात की तशखीस और जांच पड़ताल को दोबारा से करना चाहिए। आखिरी सवाल है कि क्या खतरात की तशखीस की मैट्रिक्स किसी इदारे की वेबसाइट या किताबचों में मौजूद है? तो जवाब यह है कि WHO के खतरात की तशखीसी जरीदे में 2 इकसाम के मैट्रिक्स मौजूद हैं जो कि मुख्तसर और तवील टेम्पलेट से मुताबिकत रखते हैं, जैसे कि मुख्तलिफ इदारे अपनी ज़रूरियात के मुताबिक उसको ढाल सकते हैं। थैंक यू। ओवर टू यू फिलिप फॉर द नेक्स्ट पार्ट।
Thank you. This question was about, after control measures, was about administrative controls and what is the role of administrative control. So first, administrative controls are the policies, procedures, all types of communication, training, and other means that are put in place to stimulate and manage safe practice or behavioral change of people towards safer practices. So I put there a number of examples of safe practice, like no mouth pipetting, some hand washing. These are very basic. The wearing of PPE, limitation of sharps. Also, some proactivity regarding risk, for instance, incidents reporting, awareness of biosecurity issues. All that are safe practice, our behavior that we want to promote. And so for that, we use administrative controls, and this could be written procedures like SOPs, awareness campaign, the same signage that we have on the labs or on freezers, for instance, the biohazard sign, some specific poster on the practice that we want to promote in a lab. Also training certification, the biosafety review meetings like the IBSC would do, audits and inspections. All those are administrative controls put in place in order to stimulate and manage good practices. Actually, administrative controls are a way to control risk that is considered cheaper and more sustainable than other risk control measures alone. So they come in addition to the rest, but they make them more accessible and certainly more cheaper and more sustainable than the number of more sophisticated technical measures alone. The next question was, is this new WHO approach contradictory with the hierarchy of controls? And my answer is clearly yes. Some of you may wonder about the hierarchy of controls. Actually, I could hear the different component of a biorisk management program. You have first work practices and personal protection. Then you have engineering controls, meaning all the facilities, equipment, how they work, and so on. And also the management that include administrative controls. In this case, I did not put any hierarchy. I put them on the right level, or on the same level. In this case, I am presenting you the classical way of hierarchy of controls. In this case, we first have elimination, then substitution. I explained that in the previous session. Then we have the engineering controls, then the administrative controls, and finally the PPE. And those are supposed to be put in order from the most effective to the least effective. Okay. So in this approach, we first try to eliminate and substitute risk and hazards, which is normal. But then engineering control is the next one. That means that the priority is given to engineering controls over administrative controls and PPE. In this approach, for instance, we will not use PPE unless there are some gaps in the engineering controls. So we'll really rely first on engineering controls, that mean on the infrastructure and equipment. The idea behind that is to have like automated labs where people are not present or not much present, and in that case they don't wear PPE. In practice, we are not there yet, but that's the kind of view that is behind this hierarchy of control. Actually, this is an approach which is much used in the West, and especially in the industry. However, WHO is a little bit critical towards them, and based on a number of observations. The first observation is that incidents and accidents occur also in high-level facilities, very well equipped. So it does not appear so as effective as we could first think. Also, a source of incident and accidents is also the misuse of some of those engineering controls. To be able to use sophisticated engineering controls, we need to be highly competent technically, and we need to be well trained. If it's not the case, then there might be some failures. The next observation is obvious, is that those engineering controls have a very high cost. So if you want a fancy lab with a very efficient air conditioning system with filters, with a modulation of the pressures and so on, it will cost a lot to build that lab. But then it will also cost a lot in energy consumption, but also in maintenance. Such a complex lab needs to be maintained on a regular basis, and that maintenance is done by skilled technicians, which may need to come from abroad. So it has a very high cost, including in our countries, I would say. Then the last major observation is that good engineering controls are not accessible and not sustainable in many limited resource countries and settings. So even if the labs are installed, they might not be operational after a few years because it is too expensive. And so WHO considers the hierarchy of controls approach to contribute to the shortage of diagnostic and research capabilities in many countries. Because in some way the model is based on those engineering controls, and most countries cannot afford them or cannot afford to maintain them at the right level. So clearly, the new WHO approach is contradictory with the hierarchy of controls. And actually, WHO is more focusing on sound risk assessment and kind of against copy-pasted rules based on what is done in other places. It's sound risk assessment that needs to be adapted to the local situation. And then they also focus on people. So their competences, their training, the behaviors they have in the lab, and also on administrative control. So the new hierarchy of controls that is proposed by WHO is first the good microbiological practices and procedures, and that's really the basis. And then depending on the risk, we select additional control measures to complete that. And according to WHO, that would cover most risk situations in most labs. So with those good microbiological practice and a number of selected number of additional practice, that should be enough for most situations. And actually, more complex engineering solution would only be justified but on the basis of risk assessment in rare high-risk activities. And that is what was represented by this graph, which is the risk assessment matrix. And you see that the green part is mostly, we can protect the people and the outside community and the environment with core requirements, starting with the good microbiological practice and the basic PPE. And then for some risk events that are more likely or which could have more severe consequence, then we have to select high-level control measures to really respond to those risks. And then finally, the part in red, that's a very few laboratories with a high risk. In that case, only we would require some selected maximum containment measures. Another question was about biosafety levels and how to upgrade BSL1 to BSL2 or BSL3. So can you explain about biosafety levels? I could, but I don't want to. Clearly because it's not the purpose of this webinar, but also because it's somewhat against the idea of this webinar. According to the new WHO approach, we should not base our thinking on biosafety level. We should really think in terms of risk and controlling those risks. And so I think that it will be an effort for us, but we should definitely stop thinking in terms of biosafety levels. And that's really the progress we could make in relation to this approach. Still, is it possible to upgrade a BSL1 lab? Yes, if you want to reach a BSL2 lab, that's easy because the difference between the two is mainly a matter of practice. There is no infrastructural difference between the two. On the other hand, if you want to upgrade a BSL1 or a BSL2 to a BSL3, it's impossible or almost impossible because in that case you have too many sophisticated engineering systems. It would be probably better to destroy the lab and build a new one, which will be much more expensive. But the idea here is we should really stop thinking in terms of BSL, but think about the risk in our facilities and how to manage that risk properly. Afsa, could you please summarize?
Yes, sure. Can you see my screen now?
Yes.
Thank you. Second part. खतरात को काबू पाने के इक़दामात के मुतालिक सवालात। इस सिलसिले में पहला सवाल यह है कि खतरात को काबू पाना क्या है। ये एक ऐसा तर्ज अमल है जिसके इस्तेमाल से आप मुमकिना और काबिल शनाख्त खतरात से बच सकते हैं और खतरात को काबिल कबूल हद तक ला सकते हैं। मिसाल के तौर पर दस्तानों या HEPA फिल्टर्स का इस्तेमाल। अगला सवाल यह है कि किन इक़साम के इंतजामी अमूर के जरिए हयातियाती खतरात पर काबू पाया जा सकता है। इसका जवाब यह है कि पेशे से मुतालिका सेहत के सिलसिले में इंतजामी अमूर बहुत अहमियत के हामिल हैं, जैसे कि अच्छी पॉलिसियाँ बनाना, बेहतरीन तरीक़ाकार लागू करना, मवासलात और तरबियत के मुनासिब निज़ाम राइज करना, मुलाज़मीन की महफूज तरीक़ों से कारकर्दगी या तर्ज अमल की मुस्बत तब्दीलियों की हौसला अफजाई वगैरह शामिल है और ये खतरात पर काबू पाने का सस्ता और बरकरार रहने वाला अमल है। इस सिलसिले का अगला सवाल यह है कि क्या WHO का ये नया नुक्ता नज़र पुराने से मुतज़ाद है, क्योंकि इसकी बुनियादी ज़रूरियात में शख्सी हिफाजती आलात के इस्तेमाल पर जोर दिया गया है, जबकि पुराने तरीके के मुताबिक ये दिफा और हिफाजत की आखिरी हद पर आता है। तो इसका जवाब हाँ है। ये नया नुक्ता नज़र पुराने नुक्ता नज़र से मुख्तलिफ है। नए तरीके में खतरात की तशखीस और जांच पर ज़्यादा से ज़्यादा जोर दिया गया है और इसी के मुताबिक अमल करके खतरात को कम करने की और काबिल कबूल हद तक लाने की कोशिश की जाती है। पुराने नुक्ते नज़र के मुताबिक जो दर्जेबंदी की जाती थी, इसके मुताबिक बहुत से ममालिक में तशखीसी और तहकीकी सलाहियतों का फुकदान नजर आता था, जिससे वसाइल की किल्लत के बायस बहुत से काम नहीं किए जा सकते थे। इसलिए खतरे की नौइयत और संजीदगी के मुताबिक नए इकदाम को अमल में लाना वक्त की अहम ज़रूरत है, जो कि WHO के नए नुक्ते नज़र से मुताबिकत रखता है। अगला सवाल है कि क्या आप हयातियाती खतरात से हिफाजत के दर्जात को वाज़े कर सकते हैं और क्या हम अपने पहले दर्जे की लेबॉर्ट्री को दूसरे या तीसरे दर्जे की हद तक लेकर जा सकते हैं? तो इसका जवाब बहुत वाज़े है। इसका जवाब है कि नुक्ता नज़र की तब्दीली के बायस दर्जाबंदी का निज़ाम ख़त्म किया जा चुका है। इसलिए अब हमें इस पुराने तरीके के बजाय नए तरीके के मुताबिक सोचना चाहिए। जहाँ तक बात है बेहतर दर्जे तक तजर्बागाह को लेकर जाने की, तो पहले से दूसरे दर्जे पर लेकर जाना आसान है, जबकि दूसरे से तीसरे दर्जे तक पहुँचाना बहुत मुश्किल बल्कि तकरीबन नामुमकिन है। Over to you, Philip, for the next part.
Thank you, Dr.
Thank you.
Okay, I hope you see my screen.
Yes, Philippe.
Yes, okay, thank you. The last questions were more specific questions. I still wanted to address them, but in a way that I will mostly illustrate the way we will do a risk assessment. And perhaps I will try to speed up a little bit because we lost some time with the technical issue problems. So the first question that was asked is about how to control risk of vortexing open tubes. And actually the context is put there. So in our lab, we perform manual DNA extraction from blood using phenol chloroform method. In one step, it is recommended to add SDS while vortexing the sample. So in case the tubes are open, how can we control this situation? This one I will explain because it will really show you how we should react when facing such a question. So clearly, the person who asked this question identified some risk from this activity. But the question is how to deal with that risk. And this is clearly a situation that require risk assessment. So when I present former sessions, I present the risk assessment that we do when starting a new project, for instance. But if there is a new question, if there is a risk that is perceived and so on, we can also do a more specific risk assessment, which is really based on that specific situation. And so I will not tell you what to do in such a situation because I am not in that lab. I don't know exactly the context, but I will provide you an example of the way that you should use to try to find yourself the answer to this question. So we'll do the risk assessment. We first start gathering the information. Of course, we don't know what biological agents are those samples, so we should first start to define what are those biological agents, and of course focus on all the aspects that that are related to the hazard. How infectious they are, and so on. In particular, we should ask ourselves the question: do they present a hazard by inhalation or by mucosal exposure? In which case, there would be an aerosol would be much more have more negative consequences. Also, question: are the biological agents still living when we proceed to the mixing? They could be inactivated before, and if so, is there a way to inactivate them before, without, of course, threatening the results, of course? And then in the question, we say that adding the SDS during vortexing is a recommendation. Is it just a recommendation or an absolute requirement? If it's just a recommendation, perhaps we could add it before vortexing and then perhaps vortex for a longer time, but that's a question. Also, there could be some equivalent techniques that do not require the phenol chloroform extraction. And of course, in that case, it would be good because phenol and chloroform are also hazardous substances. Also, it could be possible to add a reagent to find a technique where we don't have to reach while vortexing, but before vortexing. So you see, you should really explore the situation and ask yourself a number of questions. More questions. If there could be a way to mix the samples with the closed tubes. For instance, if you use some magnetic bead. Also, there could be, if there are some alternative techniques, are they available here locally? And how expensive they are? What other means would be used to reduce the risk of generating aerosols? And if we cannot do that, what means we have to contain aerosols, like a biosafety cabinet or a fume hood? Are they suitable for that activity? Are they functional? Also, if so, is our staff familiar with the use of a biosafety or a chemical hood? Do they need specific training on that? And if all this is not available, could some PPE be considered? So there are enough questions that we should really ask ourselves when in that part. It's a kind of brainstorming of looking at all the possible impacts, all the possible factors, and all the possible solutions. Then after that, you evaluate the risk, and you should define what is the likelihood of generating aerosol when doing that, and what would be the consequence of those aerosols. In this case, you should look at biological risk, because there are some biological agents, but also the chemical risk, because you use phenol and chloroform that could also be in aerosols, but also that could vaporize, they could emit vapors. And finally, you should define whether those risks are acceptable given your safety policy and your own personnel or not. Depending on that, you will continue the risk assessment. If it's not acceptable, in that case, you will need to define a risk control strategy. Can we eliminate the hazard or substitute the risk in replacing or adapting the technique, for instance? Can we limit the aerosols or their dissemination, for instance, using a biosafety cabinet? Or should we base personal protection in wearing PPE? So there you should really look at what would be the best general approach to do that. And then the next step, step 4, is to select the specific risk control measures. That should be based on the strategy, and we should define which technique or equipment to choose, and also make sure that everything is in place for implementation. For instance, how to make sure, if it's based on PPE, to make sure that PPE is continuously available during the period the tests are conducted. Do our people need some specific training or some instructions to do things properly? Would they feel comfortable with the proposed solution? If not, what can we do to make these sure instructions can be followed? And then finally, does the risk become acceptable after implementing all these measures? And when we are ready to implement, then we should implement. And then the last step is reviewing. We should review that, the risk assessment, in case there is an issue, like an incident, like we observe some change, in case of change in the technique or anything, or at a given interval. And of course, for that, we should also observe the application of the risk control measures, so that we can detect if there are some changes. The second question is also about a specific situation, how to proceed if we are in a situation where we could have a biological spill but don't have all the materials to deal with it. Again, this is a situations where we observe an existing situation and realize that there is a problem. We don't have the materials to cope with the spill like we should. And so again, we should assess the situation and so conduct a risk assessment. Again, I put there a number of questions. I won't go through them in much detail, but what agent could be involved? What are what is their hazards? What is their spills? Is it a few milliliters or liters or 100 liters? Where would those spills occur? In the labs or possibly in the corridors and so on. Still, what would be, are there other ways possible to limit the spills? How can we manage them? What would be the cleaning methods that could be available and so on? And if materials are not available, what is lacking? Can we replace the lacking materials and so on? Anyways, if we start risk assessment from scratch for a new activity, a situation like this should be prevented, because we should really ask those questions when doing the risk assessment. But of course, if you observe that after implementation, you should correct it, and using the risk assessment approach should allow you to do that. Then evaluate the risk against likelihood and consequences. What is the resulting risk, and is this acceptable? If the risk is not acceptable, then you should define a strategy, and then after that, based on the strategy, you should define the control measures. So you see, risk assessment should be done at the start of a new activity, but it can also be used to analyze the situations where we feel that the risk is not fully controlled, when we see that there is something abnormal. We can also do the same approach and use the same approach in such situations. Third question, can HIV culture be done at BSL2? My answer would be, why not? Anyways, I will not give a definite answer to that, because the only way to be sure is, again, to conduct risk assessment. I will just provide you with some elements of answer. First, when culturing HIV, the main risk is from accidental injection or cuts with contaminated items. And this can be controlled in preventing or limiting the use of sharps, or for instance, also replacing glassware by plasticware and so on. The next risk, I would say, would be the risk from aerosol, but it's quite limited, and it's mainly a risk of exposure of the mucosa. And in that case, we could also put in place some risk control measures based on control of aerosols using a biosafety cabinet. If you look at those two measures, they could be applicable at BSL2, and you don't need all the expensive engineering controls that are usually required at BSL3. So my question there would be, why would you want to use a BSL3 for this? Actually, I would say that of our facilities, we do culture HIV at BSL2 because of these reasons, based on risk assessments. The next question, I think, is important because there might be some misunderstanding, and I saw that in the chat box today that there is another question about this. How to manage multiple risks with different thresholds. And the question that was asked today was about the resulting risk. Is it a kind of average of the risk, or is it the sum of the risk, and so on? I think that, let me explain on the basis of the example that I used during the previous session. When we do the risk assessment, we identify a number of laboratory activities and procedures that pose some risk. And that's what we did in the first column. And then we define what is the risk. And for the first activity, we say that it was medium risk, the second one medium risk, and the two others from that activity that we analyzed, it was very low. And so when deciding if it's acceptable or not, we say no for the two first and yes for the others. So we put some priority to the two first. We don't need to do something necessarily with the others. So this sentence here about select the overall initial risk. Actually, it's the initial risk is not a kind of average or anything. It's a way to summarize the risk assessment. And actually, what we should do, since the high risk that we identified in this risk assessment, we should define the risk as medium. Okay. If you had one line there with a very high risk, for instance, in that case, the situation would be very high. It's a way to say that we need to act in priority. And then to know where you need to act, where you need to put additional measures, then you should look at this table. So clearly, the overall risk is not just a kind of, it's just a kind of summary of the risk assessment. It should underline the highest level of risk in this process. And depending on that, we'll decide if it's not acceptable or not. And all the individual risks that are not acceptable should be addressed. And that means that we should find some measures to cope with those risks. In practice, the way to proceed is to address each risk separately. If the risk is very low and acceptable, we don't need to work on them. If the risk is higher and does not appear acceptable, in that case, it has to be controlled. And the best way to control a risk is possibly to eliminate the hazard. and I will just come back in a few moments about that. That would be the most effective, the most suitable strategy for most situations. But if it's not possible, and that's sometimes not, in many cases not possible, then we need to define a strategy and to develop specific risk control measures. Actually, there is one thing that we should look for when defining a strategy, is we should look for synergies. And synergies are a number of actions that go into the same direction that tend to lead to the same results. And if we develop synergy, we could possibly control several risks using just one appropriate one approach. And of course, that's when we think about strategy, that's really what we should look for. So, for instance, if we can do elimination or substitution, in that case, we are likely to eliminate or reduce the risk of several activities. Two examples: if we can replace an infectious agent by a non-infectious or less infectious agent, it will have an effect on most of the activities. Will automatically reduce the risk in a number of activities. Same thing if we can use solid cultures instead of liquid culture, will reduce the risk of spills and consequences of spills, but also limit the risk of aerosols. So this is something we need to think about when you establish a strategy. Also, with the risk control measures, for instance, using a piece of equipment like a biosafety cabinet that offers collective protection, meaning protection to a number of people, rather than individual personal protective equipment, would also be more interesting, because it does not only protect the user of the equipment, but also the lab from contamination and indirectly the other workers from indirect exposure. So, but those are thoughts that we can really kind of challenge when establishing the strategy and also defining the control measures. And I think it's time for the last summary in Urdu, Afsa.
थैंक यू फिलिप। आखिरी मरहले का पहला सवाल है कि खुली हुई ट्यूबों के अंदर अशिया को वोटेक्स के जरिए हल करने के खतरात को कैसे कम किया जा सकता है, जैसे कि डीएनए को दस्ती तरीके से अलहदा करने के अमल के दौरान फिनोल और क्लोरोफॉर्म के अंदर एसडीएस को दौरान वोटेक्स कतरा कतरा करके शामिल किया जाता है। तो इसका जवाब ये है कि ये एक बहुत आम मिसाली सूरत हाल है जिसमें आपको खतरात की जांच पड़ताल की जरूरत पड़ती है, और इस अमल के 5 मराहिल हैं। पहला मरहला है मालूमात जमा करना, यानी क्या इस काम में कोई हयातियाती खतरा या कोई मोहलिक जरासीम मौजूद हैं, इसकी नोयत और संजीदगी कितनी है, क्या ये अवाम में फैल सकता है और अगर हाँ तो कैसे फैल सकता है, क्या इसके बायस होने वाली बीमारी का इलाज या इसके खिलाफ वैक्सीन मौजूद है, क्या जो लोग इसे इस्तेमाल करेंगे वो मुनासिब तरबियत याफ्ता हैं, क्या मुनासिब आलात और शख्सी हिफाजती आलात मौजूद हैं, वगैरह। दूसरे मरहले में देखा जाता है कि किसी खास काम के बायस पैदा होने वाले खतरात किस नौयत और संजीदगी के हामिल हैं और क्या वो काबिल कबूल खतरात हैं। तीसरे मरहले में इन खतरात पर काबू पाने के लिए मुख्तलिफ तरीक़ाकार ज़ेरे गौर लाए जाते हैं जिनकी मदद से खतरे को कम से कम किया जा सकता है, जैसे कि कोई मुतबादिल तरीका अपनाना या हिफाजती आलात के इस्तेमाल का मुमकिना मुस्बत नताइज को ज़ेरे गौर लाना वगैरह। चौथे मरहले में तमाम मुमकिना हिकमत अमली के तरीक़ाकार में से एक को चुनना और इस पर अमल दरामद कराना है। इसमें यह ज़ेरे गौर रखा जाता है कि इस अमल दरामद के लिए तमाम ज़रूरी अशिया और सहूलियात की फराहमी को यकीनी बनाया जाए। पांचवें यानी आखिरी मरहले में पिछले मरहले के नताइज का जायजा लिया जाता है और अगर किसी तब्दीली की ज़रूरत महसूस हो तो इसको अमली जामा पहनाया जाता है ताकि खतरे से हिफाजत को हर मुमकिना हद तक यकीनी बनाया जा सके। अगला सवाल है कि अगर हमें ऐसे हालात का सामना है जिसमें हयातियाती मादे के गिरकर फैलने का खतरा है लेकिन हमारे पास इसे साफ करने के लिए ज़रूरी सामान नहीं है, तो ऐसी सूरत हाल में हमें क्या करना चाहिए। इस सवाल का जवाब भी पिछले सवाल की तरह है, क्योंकि ये भी एक ऐसी अमूमी सूरत हाल है जिसमें हमें खतरात की जांच करनी होगी और इस सूरत हाल में भी वही 5 मराहिल इस्तेमाल किए जाएंगे ताकि गिरकर बिखरने वाले हयातियाती मादे के खतरात को काबू में लाने के लिए मौसर हिकमत अमली तैयार की जाए। इसमें इस बात का ये जोर देना मुनासिब होगा कि अगर WHO के तजवीज़ करदा खतरे की तशखीस के अमल को ठीक तरीके से इस्तेमाल किया जाए तो इस किस्म की सूरत हाल रुनुमा होने के इम्कानात बहुत कम हो जाएंगे। अगला सवाल यह है कि क्या हम दूसरे दर्जे के हयातियाती हिफाजत के इंतजामात के साथ HIV का कल्चर कर सकते हैं? इसका जवाब यह है कि बिल्कुल कर सकते हैं, लेकिन इसके लिए हमें पहले खतरात की तशखीस और जांच पड़ताल करनी होगी। जैसे कि HIV के मामले में किसी नोकदार और तेज धार चीज के इस्तेमाल से जख्म लग जाने का खतरा होता है और इससे बीमारी लग सकती है। इस सिलसिले में तेज धार आलात का कम से कम इस्तेमाल और बायोसेफ्टी कैबिनेट का इस्तेमाल खतरात को काबिल कबूल हद तक कम कर सकता है। आखिरी सवाल यह है कि मुख्तलिफ किस्म के खतरात जिनकी कबूलियत की हद एक दूसरे से मुख्तलिफ हो, इन तमाम को इकट्ठे किस तरह मुनज़्ज़म किया जा सकता है और इनको किस तरह महफूज बनाया जा सकता है कि एक ही खास काम से वाबस्ता तमाम खतरात को इकट्ठे या अलग अलग तरीके से कम करें। इसका जवाब यह है मजमूई खतरा। ये वो अल्फाज हैं जिन्हें हम खतरात की जांच और तशखीसी अमल का खुलासा कह सकते हैं, जिसमें सबसे बड़े खतरे को खास तौर पर ज़ेर गौर लाया जाता है, जबकि दर हकीकत हर इनफरादी खतरे को अलग-अलग देखा जाता है। कम और काबिल कबूल खतरात की मौजूदगी में भी काम किया जा सकता है, लेकिन बड़े और नाकाबिल कबूल खतरात से निपटने के लिए जामे हिकमत अमली की ज़रूरत होती है, जैसे कि बायोसेफ्टी कैबिनेट के इस्तेमाल से बैक वक्त कई मुख्तलिफ किस्म के खतरात से निपटा जा सकता है। शुक्रिया। That's all from my side.
Thank you, Afsa. Yes, it's now the end of this webinar, and I want to thank you for your participation. I saw that there were a few additional questions, and I won't have time to answer all of them, of course. There is one I want to answer for the people who are still there. One person asked about BioRAM, which is the Biorisk assessment technique proposed by Sandia. I participate to the construction of that system, and I would say you can forget about it. Why? Because it's a kind of black box. You put a number of items into that, and according to that, it gives you a score that tells you what to do. But we don't have any qualitative analysis of the risk, and so you might end up with the recommendation of some control measures that are not adapted to your reality. So really, you can forget about it. And I said it when I participated to the construction of that system, but yeah, I think it's outdated now. So thank you very much for your participation. As I said at the start of this webinar, the hope is that there will be some practical session where we'll really be able to do some biological risk assessment together based on very realistic situations that you know. I hope this will take place. But anyways, I'm sure that there will be more initiatives and that you will also be able to work in different situations on risk assessment. So I really encourage you to try to shift your mind and to adopt this system, because I think there are huge benefits for you in Pakistan. So thank you again, and I hope you enjoyed.
Thank you, Philippe and Dr. Hafsa, for giving the presentation, and thank you participants for joining. Please make sure to save the link, the evaluation link, क्योंकि उसी के बुनियाद के ऊपर आपको आगे दिया जाएगा quiz का link. We're going to keep the session running for another 5 minutes, after which point we will close it. I'm going to be sharing the link one more time ताकि आप सब जो है वो कर सकें. Thank you for your patience, everyone.